Because I'll show you in a second, okay? All right, so let me go ahead and look at this one here. So now, this is the fourth link, which is the output. So I move my ruler perpendicular along that line of action of that force until I see where it intersects I-14. So this right here is our perpendicular to this. Whereas this one here was perpendicular to this. Okay? Now what I'm going to do is I'm going to draw this little diagram here. Here's our out. Here's F out. They always have to be perpendicular if you did it right. And here is R in. And here is F in. So you're looking at R crossed into F. So with this one here, when I cross R into F, I get a plus R in times F in. Okay. And here, if I cross R out into F out, I get a minus R out times F out. So going back to the question Alice just asked, why am I redrawing those vectors? It's because I want to draw those little diagrams.
Is there a reason why that vector would ever be in a different direction?
Yep. It would be if it's on an output, it's coming from the mechanism to the outside world. If it's on an input, it's always coming from the outside world towards the mechanism. Okay? You'll see this in the next conversion that I do. Okay.
Can you explain how to get the direction of R?
Yep. So the direction of R is coming from the grounds, in this case I-14, towards the force. So I take that direction, put it there. Okay? I already drew this direction here, I put it here. From the ground to the force, I take that direction, I put it here. This here. Okay? Then what I do is I write my power in versus power out equation. So power in, I think I wrote that stuff right. Yeah. So on this one here, I look at the sum of the torques in, and I get a plus R in times F in times omega plus times a positive omega 3, which equals a minus R out times F out times a minus omega 3. So notice here that the negative signs cancel out here. And then on this here, we solve for F out. Now, the omega 3 over omega 4 ratio is found from here. All right? So to summarize this problem, I'm not going to work the whole thing. But to summarize this problem, you measure 1, 3 to 3, 4. Physically measure that distance there. You measure 1, 4 to 3, 4. Physically measure that distance there. Now, you can use any units you want. You could use miles. I don't suggest that. Right? I would suggest using centimeters, maybe millimeters. So you physically measure those distances. You physically measure the distance RN from there to there. Physically measure it, get that in centimeters. You measure R out from here to here. Okay? These are all ratios. So that's why the units cancel out. So choose a good set of units, being centimeters or millimeters, and find the ratios, and you'll find the mechanical advantage. Okay? So I'm going to do the next inversion now. Questions on this one here?
So
On how to
this is the
solve it.
easiest one?
Hmm?
You said this was the easiest one?
This is the easiest one. And in years past, I mean, I gave you the answer to this thing here, right? It's like 190 or something for F out. So this problem here, I use every semester. And I know the answer is out there somewhere, okay? But, actually, now that the solution is out there somewhere. But in order to do well on the exam, you should know how to do all three inversions on it. I'm going to do the second and third one now. Okay. All right, so on the next one, what I'm going to do is I'm going to ground, not a good choice, but I'm going to, well, not a horrible choice, but I'm going to ground this